Yeah. Today we talking about the trade 2, electrical trade 1. We talking about the converting the circuit diagram to the wiring diagram. So in this case, when you convert the circuit diagram to wiring diagram, it can include the assembly and the wiring of the equipment, or not important for the single circuit. For the complex circuit, wiring diagram is essential because before you are doing these complex circuits electrical installation, so you have to do this wiring diagram. Without wiring diagram, if you do the job without wiring diagram, it can cause a wasting of the cable, and also the unnecessary larger cable long, and too many conductors terminated at the given terminal. So that in this case, we have to utilize the numbering system for the cable terminal. So here is a conduit wiring. So this is circuit diagram, switch and the light, and here will be the this is a conduit. So there will be the red is the active color, active wire, black is a neutral wire, and the green is the out wire. So they are and in this case, the red and this is the blues are the light terminal, so that they are connection of the circuit. And also this is for the conduit wiring diagram. So the conduit installation, we can have this is the one conduit. And then you can add, and here is a light, and here will be the switch, and this is a switch wire conduit. So we have to do as a wiring diagram like this. So this is the predicate construction. So also the one switch control as a one light with the conduit loop as a switch. So this is function is a loop as a switch method. One switch controlling a one light. So there will be the adding you can add wire coming here, and here you can terminal, the switch terminal, and this wire go to the adding nuclear like this. So this is what the connection diagram. We can draw the conduit diagram like this. So this is where the how do the wire at the circuit diagram and the conduit wiring diagram. And here is a look at the switch method. Look at the switch method. Look at the switch method. This is for the connection diagram for the look at the switch method diagram. And here is the conduit diagram. So in this case, we had to talking about the cable duct. So the cable ducts are the raceways. They are also passage for the cable. We need to install the duct. So the when you are doing the installation of ducts, firstly you have to fabricate a sheet metal, cut the sheet metal and form the shape. So they fabricate the sheet metal, and then you have to install that sheet metal on the wall. So in this case, we have to draw the cable into this cable duct. We have to draw cable into it, and then you have to form a pipe up to 75 millimeter diameter, and also if up to 75 millimeter diameter, you can utilize a pipe. But for the larger one, we have to use a trunking system. Then we have to use, if you using a bundle cable, the cable currents are rated to be derated. So this is the long wiring diagram. Long wiring is the harness wiring. Our wire harness cable assembly, they are put into the cable harness assembly. So the function is to transfer the signal or the electrical power. Cables are bundled together by the strap, cable tie, cable latching, and the sleeve and the conduit. So this is another thing, the suspended ceiling. When you are running a cable above the ceiling, you have to follow the AS3 by 9 by 3 by 2, AS3 down there, cross 3 by 9 by 3 by 2. So this is the cable here, this is for the ceiling. Cable share, these are provided with the additional mechanical protection. So the whole cable need to be provided with the additional mechanical protection. So that in this case, if without mechanical protection, some of the animal, such as a rat, can cut out the cable. And cross 8 by 3 by 6 is a AS3 long there. So it mentioned about the cable insulation system. Cable insulation system must be tested with the mega. So in this case, we have to put the fire level DC ray, and we have to test the cable resistance. Resistance between the live wires and the live wires through the earth must be the minimum of 1 mega ohm. The minimum size of the TBS cable is 2.5 square millimeter. So we have to follow the 3000 table 3 by 3. Minimum conductor size required for the lighting circuit is 1 square millimeter. So we reference is at table 3 by 3 AS 3000. Another question is what separation is required when the installation of 34 and the low voltage cable in a scatter tap. So the separation of the telephone cable from the low voltage or high voltage cables. We have to separate the telephone cable from the low voltage or high voltage cables. In this case, we have to follow the ASCS 5009 or the figure 3 by 9 or the AS3000. So this is for the cable trunking. If you run the cable trunking, the trunk or the toolbar, the housing and the protection, electrical cable and the conductor. So that will be the comply with the cross 1x4x127 or AS3000. Now this is question 5. What is the polarizing polarity of the three main socket outlets? So in this case, cross 4x5. So the left side is the active, right one is neutral, and the bottom one is arc. So cables are tapped. Cable that's how we need to follow the ASR 1x4x45 or the AS3000 standard. A pipe of the 75mm diameter greater on the closed passage found the underground or the any structure and the identity to receive the one or more cables are done may be thrown in. So this is all that one has to be followed. So that in this case, question 7 it is permissible to use a single insulated cable in a PVC trunking. So answer is yes, because we follow the ASR 3x10 by 3x1. The next one is that areas are likely to be disrupted. If the area is likely to be disrupted, what you have to do is cover all the wiring enclosure containing the unsheathed cable, shall be effectively related in a position and shall not be removable without the use of tools. So this is the name must follow there. Yes, 3000 closer 1 by 10 by 3 by 2 by 1. The next one is a minimum spacing of the minimum spacing for the spool of the cable in the position likely to be disrupted. So in this case, we have to follow the AS of 3 by 4 by 3 by 3. Question 10 is adding conductor side. So to select the adding conductor side, we require the cable 5 by 1 or the AS 3000. So depending on the adding wire, we have to select the appropriate side of the conductor for the adding conductor. So then in this case, electrode type depends on the adding conductor side and the electrode type copper for the aluminum. So socket outlets are diagrammed here. This is a socket outlet. So this switch here, this is a light, and this is for another switch, socket outlet. One switch control one light plus socket outlet, this diagram. So this is the socket diagram. This is accurate wiring diagram. The next one is the minimum spacing. Minimum spacing for the spool of the cable in the position likely to be disrupted. In this case, we have to follow the AS 3 by 9 by 3 by 3. Adding conductor side. Adding conductor side is we need to apply the cable 5 by 1 or the AS 3000. So it depends on the adding conductor side and the electrode type, copper or the aluminum. So conductor outlet here, this is switch, this is the so my one is control on light plus socket outlet. So this is for a loop diagram. This is a pretty good drawing diagram. So red is the active, black is the neutral, and the gray is the arc. So cable dust in this case we have to utilize up to 75 millimeter square. We have to utilize a conjugate and greater than 75 millimeter square diameter. We have to utilize the cable dust. So the next one is for the electrical cable schedule. So when you make any electrical installation, the first thing that you have to do is a drawing, and then you have to provide the cable schedule. Cable schedule provides a specific detail related to the cable installation. Outlets are schedule is a list, specific diagram regarding the outlet and lighting point. Appliance schedule is a detail of the specific requirement related to the installation of appliance and equipment. Those things are cable and the schedule have to be followed. Here is the cable schedule. Terminal below one. This is a terminal A, B, C, D, E, F. Terminal below D is a B, C, D. So in this case, this one so is a join between the A touching for the cable touching for the B and C cable, holding for the A and C and B cables are keeping connected between the D and E, and also the cables are 18 is connected between the E, and cable F is connected between the F and E. So this is what the cables are diagram. So this diagram is a predicate diagram, but this one you have to combine. This will the summarize a form you can draw like this. So in this case, those are forms we have to move up. This is for the cable. So when you are making the cable schedule, so number, in this case number, and then you have to put the color and the size of the cable type from the point to the point. Those things are important. When you write the cable schedule, you have to put the serial number and also the color of the cable, size of the cable, type of the cable, type 1 or type 2 or type 3, and the connection is from this point to another point. So this is the cable schedule. The terminal cable schedule we have to be provided like it. Therefore, by knowing the cable schedule, then you can select the appropriate cable to do this practical wiring. So that cable schedule is a connection. Number 2 is a color is a red, and cable size is 1 meter square, type is a T1, and from TV1 to A to the TV2 to A. So this is the way sample diagram how to write the cable schedule. In this case, you have to mention about the cable color and the size of the cable and the from point to the another point. And terminal route schedule here wire from wire 2. So in this case, you have to put a terminal route. So relatively rotational item for the terminating arrangement and identification of the market cable. So those are also important, and also we have to follow the special wiring equipment. So here is a terminal block diagram. Terminal 1 to 2 is a cable, you can see cable name, and here is summary form. And this one is a control diagram. So that control diagram is the control block, and this is red is active, blue is another active, green black will be the neutral, green is R. So in this case, wire from here you can write down here the wire Y1 to Y2. So Y1 to Y2. In this case, there is a number of the conductor. Number of the conductor is which conductor is connected. So here is conductor D1. Conductor D1 is joining between the node 1, A1 and node B, D1. A1 and D1. The cables its connection is cables R. Red color cable is connection. So this is the ways of by referring this diagram. You have to write down the cable color, connection to point, and kind of the wire and the connection. So this is the ways you have to sample all the cables are scheduled. So after the theory, you have to do the predicate. The today predicate is you have to follow the one light control two-way switch. So this is a two-way switch diagram, circuit diagram, and this is a predicate connection diagram. So you have to connect the two-way switch by refining the two diagram on the wiring row. Single link control by single switch. So this is a circuit diagram. This is a predicate, a lamp panel, and this is a fuse, and this is a switch panel. So this is for the circuit diagram, but here is a connection diagram really. So based on this one, you have to draw the connection diagram for the given circuit. In this case, one switch controlling the two lines. You have to draw yourself. So this is the cable schedule diagram. So this TV1 to TV2 connection. So this is the number. This is the number. Those number here. So those number connection, and also the red color of the cable and the size of the cable. And also type, you have to do that drawing this diagram. Also do this exercise, cable schedule exercise. And also the do the cable schedule for that one. That is why the singles are then controlled by the parallel connected switch. So these are S1 and S2 are parallel connection. These switches are parallel and the single line control. So then we also be that you have to complete this circuit diagram, you have to complete the physical diagram. The next one is the circular TBS cable. Circular TBS cable are used in the electrical and telecommunication system. They are shielded for the high RF voltage protection. Cables are derating is important because if you run the cables are many cable, in this case, cable need to be derated because it can get as an overheat. So if necessary to reduce and minimum maximum drag cable can carry. This is cost is derated. So this is the cable can be run on the heavy duty radar. And also supporting, you have to use a high level of air circulation. Here is a cable and a cable tray. So in this case, less expensive wire range on the cable, easy to put into the debelings profile, need to be must be supported, and less air circulation. So this is for the cables tray. This is for the ladder. So now is when you are running the cable, this is the horizontal spacing and this is the vertical spacing. D6 is the cable diameter and single cable. So vertical cable, this is the sample of the vertical cable for the horizontal spacing. The sample of vertical cable for the vertical spacing. The cable support has to be provided. Tie the cable on the tray at the suitable interval. Also, the cable must be waterproof. You will see the cable entry to the associate. So this is conduit, and we have to put the conduit C. Because of that, wire can be removed. Okay, so compression glands also connected. Compression glands they are nylon or the metals chrome plate. So industrial international production system, we have to follow the ASR 60659. So here is the production against a hazardous material wire. In this case, we have to follow the IB. IB0 is a no protection. IB1 is a full protection of 50 millimeter. IB2 is a full protection for the 12.5 millimeter. IB3 is a access probe 2.5 millimeter. Share not go the phone track. And also the IB4 is a access probe 1 millimeter. Share not go do this phone track. And also 5 is a limited ingress or duty and say the total protection and growth. So those are the kind of this IP protection. We have to follow the thing. And safety issue is also important. I must have the resistant resistant insulin resistant. You have to do this appropriate plan. No transposition or conductor and no short circuit. Those are internal interconnection with the loop impedance and also RCD operation. So this AS3000 cross 8x3x5 to 8x3x10 is not mentioned about this cable safety installation. So that when you are install the cable, the appropriate AS3000 standard need to be followed. So that those are the clocks. Clocks are 3x9x 3x3, 3x9x4, 3x9x6, 3x9x3x3, 2x8, 1x4, 0.40, 1x2, 6x3, and also 6x7 appendix G. Those are appropriate Australian standard AS3000 wiring rules are clause to be followed. Okay, this is for the electrical trade 1. So trade 2 is also, we're talking about the trade 2. So last week we talking about the G063. G063 we printed the base at 65. So that we find out there's a base 66. G063 what will answer? So in this case, clause of 7 by 4 by 8 by 1 is mentioned about the testing requirement. In the meantime, testing requirement, separation of the is a separated circuit, transformer secondary wiring, isolated wiring, the wiring to socket outlet, shall be individually confirmed. Spreadsheets are here verified by the measurement of integrating the system. We do the spreadsheet of the circuit. So if the transformer is so on the spreadsheet, the circuit, it transformer by winding. No other winding, and the other one will the circuit and arc. Those have to be done, you have to do the appropriate installation of the system, need to measure. Installation of the system value open the share of business than 1 mega ohm, and when that's with the body of the power for DC. So this is the ND wire, they master the installation of the system, at least 1 mega ohm. And this is the system you would expect to measure between the equipotentially are bonnet up in on the multi socket outlets, connected as an isolated circuit. In this case, the binary connector continuity, they must have the 5 ohm. And also the switching device, we have to read the clause 4 by 7 by 1 regarding the switching devices. They are for the cooking applied. So the switching the system switch should be mounted with 2 meter on the cooking applied. So that if you run this wiring to the cooking applies, then maybe the cooker. So we have to install the switch with 2 meter on the cooking applies. That is also important. And clearance from the OGS survey also important. Socket outlet and the switch cannot be installed in a prohibited location, showing the figure 4 by 17 or any wall. Cable or other survey with the 120 millimeter on the edge of the open gas or the electric current survey. So those are we have to follow the starting point. We can install the any switch. So we have to follow this thing. And also 7 by 2 by 5 by 4 are talking about the interposing switch for the fire part and the fire control equipment. So no switch shall be interposed between the main switch and the downstream switch board, supplying the fire part and the fire part control equipment. So here is the protection against the indirect contact. Contact with the conducted part is a light, normal surface. So this is for the direct contact. So insulation for connection can be the insulation failure or the contact to light bar. Electrical iron that can cause electric shock can be the electric iron ray, electric motor, and transformer. Protection for protection must be protected against the. So in this case, we have to follow the clause 1 by 4 by 98 for to providing the protection for. Protection for the protection against the danger can be arise from the indirect contact with the light bar or the insulation. So this is also in this case, we have to follow the clause 1 by 4 by 78. So this is the connection dashboard. So this was the connection diagram dashboard, and this is for the electrical equipment. This is FA nuclear arc connection like this. Accessible and the red leads are you have to refer the clause 1 by 4 by 2 regarding the accessibility and the red lead. Given the waiver of these bids are reached for the inspection, maintenance, or the repair, but does not include the disrupted dismemberment. So this is for the structure component. So this is the we are mentioned about the any accessibility. This is a definition for the accessibility. Also, you have to read the clause 4 by 3 regarding the accessibility value. And clause 1 by 4 by 125 the touch voltage. So this is a definition of touch voltage. And also the clause 1 by 4 by 94 is mentioned about the touch current. Those also have to read through. And also the clause 1 by 5 by 5. So in this case, the wiring loop had to be set up. So those wiring loops are the methods of the protection. Clause 1 by 5 by 2 is providing the method of protection. Protection against the indirect may be provided by the one of the any combination of the following methods. The method of protection is that you have to read the 1 by 5 by 5 by 2 or the three of them. So it mentioned about the flow protection, also the automatically disconnection, prevent the outflow current, prevent the fault current from the passing through the body. So those things are included in the clause of 1.5.5.2 or AF3. And also the protection by the automatic disconnection of supply also important. So we have to follow the ASR 1.5.5.3, the protection by the automatic disconnection of supply. Provision of the system or the equal potential bonding in which the H4 connected parts are connected to protected lights are protected others are connected. So this is the definition of the protection, automatic protection. Also the clause 1.5.5.3 mentioned about the touch voltage limit. So touch voltage limit in the event of the fault between the light bus and the H4 connected part, they could give a rise to the protected touch voltage exceeding 50 volt AC or the 100 volt river free DC. A protected device shall be automatically disconnect the supply to the circuit or the electrical equipment are concerned. So in this case, we are talking about the clause of 1.5.5.3. Clause D is a disconnection die. The maximum disconnection for the 230 volt, 400 volt, 740 volt, must not be AC there. So in this case, 30 seconds for the final circuit. And socket outlet having the rated current not exceeding 63 ampere. Also, we have to mention about the brand hand class equipment and portable equipment included in the menu as a mobile unit. The disconnection time for the maximum disconnection time of 230/400 volt. This supply is a 0.4 seconds for the final short circuit test applied. 5 seconds for the other circuit, including some final short circuit applying fit on the stationary equipment. So the automatic disconnection of supply rely on the combination of two conditions. So this combination will depend on the upward loop. Also the upward loops are needed. And also that this one does not include the automatic operating current. This is a simple diagram. This is what the block diagram you can draw it. And now this is a touch voltage applying is a right to the body about 240 volt AC. In this case, we have to provide with the circuit breaker. It need to provide the circuit, protect the circuit. The circuit breaker must operate with them prescribed time isolated for current. So to ensure the final operation of the circuit breaker, the currents are flowed into a upward must be high, and therefore the outlook for loop impedance must be low. Now there is a protection by the electrical separation. So the general requirement for the protection by separation, so isolated supply have been the covered in section 2 of the workbook. So that in the section 2, you can know about the protection by the electrical installing separation. Also, that we're talking about the consumer may is mentioned about the clause of 2.5.1.2. Read the clause 2.5.1.2 regarding the consumer may, the definition of the consumer may, how to protect the short circuit protection. Those things you can read on the consumer may. And you also read through the clause 7.4.5, 7.4.6 regarding the single item electrical equipment, supply to multiple item electrical equipment. You have to read through. And also the other conductor definition is a refer the clause of 1.5.5.1.5. So protection by the electrical separation. Protection by electrical separation, the identity in the individual circuit to prevent a short circuit through the conductor with a conductive part. That might be the energized by the force in the basic insulation of the circuit. Protection by the electrical installation must not be connected at any point to the another circuit. So this is an important aspect. If you do this protection by the electrical separation, if the circuit shall not be connected at any point to add or to the circuit. So any protection bonding conductor associated with the space circuit shall not be connected at any point to the earth. And also the clause 1.4.98 is a definition of the body, and also the protection, and also the clause 1.4.128. This is for the reference extra low voltage. Extra low voltage not exceeding 20 volt AC or 120 volts river free DC. And also protected device may be the circuit breaker, fuse, and page 83 mentioned about the use of the fixed setting of the RCD. So this is a requirement for the additional protection, also important aspect because of the maximum rated residual current of 30 milliampere shall be provided for the final circuit. And also the lowest residual connected by RCD. The RCD, the device identity to isolate the supply, to protect the socket outlet or electrical equipment in the event of current flow to up, then AC that be determine the value. And basic protection are not recognized as a something of the basic protection. So RCD are not a basic protection. RCD are recognized as meaning of providing automatic disconnection is also important. So the RCD recognizes the meaning of providing automatic disconnection of supply. Across level, they cross 1 by 5 by 5 by 3. So the clause of 2 by 6 by 3 by 2 by 3 by 3 is a requirement for the additional protection. In this case, socket outlet lighting, direct the handheld electrical equipment, we have to provide with the additional protection. So the wiring systems are specified. So in this case, clause of 2 by 6 by 3 by 2 by 1 is a classification of the wiring system. So in this case, it includes the final circuit, this supply the extra low voltage across with the cross 7x5, or the final circuit supply from the splitter supply across with the cross 7x4. Electrical heating circuit with specifying the cross 4 by 10 by 5. And also the 2 by 6 points are 3 by 1 is a general. The requirement for the disk clock for installation of RCD are additional to the RCD requirement for electrical installation. So in this case, we have to use the file AS are 3001, 3002, and 3003, and 3004. So this is the mention about the how to install the RCD. Also, the sections are 3 for the production and gate mechanical damage in the year 3010. Section 6 is the bus shower and other water container, and section 7 for the electrical installation. Also, the dense saturations are you have to read the cross out 1 by 4 by 40. Dense saturation dividers and dense. So this is a dense saturation definition. And slashing and the installation. So and these are equipment when you are installed. So they need to provide with the enhanced protection, provide the enhanced protection or provide the adequate protection. So this is also an important aspect. So here 3000 also they are mentioned about the electrical installation and dense saturation. Dense saturation include the flash shower and other fish water container, swimming pool, bathing pool, spa pool, sauna, refrigeration room, sanitizing area. So international production rating is an IP. So it also the value about the first numbers are from 1 to 6. This is for the degree of production. Second number 1 to 8 is a degree of the production. So it's also important. So this is for the reason is this one. There will be the IP rating. Something of the IP rating. Socket outlet rated IP66. So this is a socket outlet specification. You have to read this page. And also the limited ingress of gas permitted no harmful. In this case, the first number 5, protection engage the spray is to the 60 degrees. So in this case, from the particle limited ingress permitted or this section. Second number 3, IP53. So these are how to interpret the protection IP rating. So here we need the IP ratings of this exercise. And table 6.1 is mentioned about the selection or installation of electrical equipment for bath shower and other fish water container. So if you want to install the electrical installation in Paro or any templates, you have to follow the table 6.1 or ES3000. Also the table 6.1 of the ES3000 are mentioned about the ES3000 mentioned about the protection zone and also the IP rating. Those things you have to read through. And here is this diagram show about the protection zone. Zone 0, zone 1, zone 2, zone 3, like this. And this is a protection of the. And also we have to use the exercise, you have to do the exercise. And here I gave a 6.2 a selection of installation of electrical equipment for swimming pool. So if you want to install the electrical installation in swimming pool, so depending on the equipment, zone 1, zone 2, and you have to supply this table and how the civil authority permitted or not, IP rating, you have to also apply it. So also the cross of 5x6x2x5 is bonded in the dense circulation. So in this case, you have to use the equal potentials bondings conductor, and also side of the equal potential bonding conductor and protected piping, shower barrel, swimming pool area, how to run the protection equal potential bonding conductor, and also the not less than the 4 millimeter square. So cross-sectional area of the equal potential bonding conductor for swimming pool maybe determined for is the arcing conductor. So also the tables are swimming pool is far pool is you have to refer the cross 5x6x2x6. So in this case, and how the run the electrical equipment, and how the what is any export connected bar, how to connect it to the arc connection. So are included in that cross 5x6x2x6 for the swimming and the spa pool. Also, we also need to provide the minimum CSA requirement for the equipment components they must be the within the armpits of the pool edge. We have to how to install it. Also, the cross 5x6x3 is mentioned about the bonding conductor. How to run the bonding conductor, where you install the bonding conductor, you can also run it. So here is this table, you have to do the exercise. So this is for the trade 1 trade 2 aspect. Then we are talking about the advanced diploma applied engineering. So we do talk about the DC circuit. So last week I have already explained you about the DC theory 6, 7, 8. Now we continue. Now we're talking about the 9. This is theory, and now we're talking about 6, 7, 8. Okay, we're talking about the electrical power of the applied electricity DC circuit. So we also you have to review the effect of the electric current. Here is a reading on the meter and also EMF. So now we're talking about the electrical power. So at the end of this session, the student should be able to state the power relationship in a DC circuit, calculate the power distributed in DC circuit, draw a circuit connection for the 1 meter in DC circuit, select the appropriate resistor for DC circuit, use a volt ammeter method to determine the power consumption in DC circuit, and use a 1 meter method to determine the power consumption in DC circuit. So the power equation is a P equal to VI. Here the voltage I is a current. So this is a connection of the electric turbine 24 DC, the switch, and the 5 ohm resistor. So when you connect, current will going down like this. The current is we mentioned about the flow current is 4 ampere. Then we can calculate the power, but P equal to VI. In this case, the voltage is 20 volt, current is 4 ampere. So 20 multiplied 4, you got 80 watt. So it's supply voltage double, current also double. So in this case, the current supply voltage double, the current double, so the supply voltage is now 80 volt, current is 4 ampere. So that will be the 320 watt. So power increase by the 4. And when the voltage are triple, current also triple. So in this case, voltage current is a voltage is 60 volt, current is triple, so 12 ampere. So the 60 watt multiplied by 12, power becomes 720 watt. Therefore, the providing the resistance in the circuit remains constant. Power is proportional to the square of the voltage. So from the P equal to VI and the I equal to V by R, we can write down the P equal to V multiplied V by R. In this case, in the place of the I, you can put as a V by R. So this V and V multiply, so P equal to V squared by R. And from the P equal to IR and the V equal to IR, you can see that the P equal to I multiply I make R because of the P equal to VI. So in this case, V is equal to IR. So IR multiply another I. So this is P equal to I square R. This is power equation. P equal to VI. When you transpose the equation, I equal to V by R. So equal to V into V by R. So the P equal to V square by R. Now the V equal to IR. P equal to I multiply R. So the P equal to I square R. So therefore, to calculate the power, you use an equation P equal to V square by R or P equal to I square R. So this is the connection. This is a connection diagram of the power meter. So here I give you the 1 meter MMP and so when the current connection, the current will be flowing like this. Power is a voltage coil must be connected. So in this case, MA is a current coil. We want to do the voltage coil. So we have to connect like this. So we also have to do a practical exercise. Now we also mentioned about the watt, energy, and power. At the end of this session, students should be able to define the time associated with the watt, energy, power, state the unit of the time associated with the watt, energy, and power, calculate the value of factors associated with the watt, energy, and power, calculate the watt time in the electrical circuit, define the time, power in and power out, and losses for energy transfer system. You also have to mention, we know that calculate the efficiency of electrical applies. Now, for is needed to read the 25 kilogram of ground, 2 meter in 5 seconds. And this is 25 kilogram, you have to read 2 meters. So F equal to MA. And mass is acceleration. So in this case, mine is 25 kilogram. Why is acceleration A? A equal to gravity because of you have to read. So acceleration gravity 9 meter per second square. Therefore, the F equal to M A, so that in the place of the M you substitute 25, A is a 9/8, so that 25 minus 9/8, you got a 245 Newton. How much watt is done? What is the time energy used to move the object some distance? So what is expressed in joules? So watt equal to energy. Energy is also equal to watt. So the what is done to make the 25 kilogram block the 2 meter in 5 seconds. So how much energy is needed? In this case, 25 kilogram you want to live is a watt time finish. So that will be the 2 meter height. So F equal to W equal to F multiplied by S. Watt equal to force by distance. So force is a 245 Newton. We already know. And distance is when you are living the 2 meter. So S is 2 meter. So W equal to 245 minus 2. You got it 490 joules. How much power is used? So power is the rate of the doing the work. We measure in the joule per second. The joule per second equal to watt. So that we have to write this block. How much power is needed to get the 25 kilogram about 2 meter in 5 seconds. So we live in the 25 kilogram by 2 meter. So in this case, power equal to W divided by T. So the W equal to 490 joule, we got T is at 5 seconds. So the power equal to 490 by 5, so joule per second or 98 watt. So therefore, the W equal to P equal to VI, or the P equal to V square R, and W equal to V multiplied I, or the W equal to V squared by R. So those are the equations to calculate the power. In this case, also that we also write down the power equation P equal to I square R, or P equal to W equal to I square R as well. So this is a nature average and nature test. Also, this is the reading. So when you read this bill, so you can also see the how much how much gas waves are utilized. So then you can read. So the chart is a per megajoule. They are paying for the energy. So in this case, this is for the sample of the energy bill. So maybe. So in this case, kilowatt hour meter is the power multiplied time. So 1 kVA here 3 by 6 of megajoule. So this is the energy in, energy out. So in this case, when your energy in, some sort of energy is used for the heat, overcome the pressure, overcome the windage, and the remaining will go to the output. Power is equal to VI, and losses are the copper loss and iron loss. So we calculate the copper loss I square R, iron loss is the V by T, and then output power is the P equal to V by T. So this is the way you got output power. Not all energy that is put into system use efficiently. So we have to know about the efficiency. Efficiency power output by power input. So the practical exercise 7, you have to do the feeding efficiency. So this is the number 6, and also we talk about the number 7. So we talking about the applied electricity. These are the resistance of material. We have to review the electrical power, what energy power, and you have to do the quiz. So resistance of material. At the end of this session, students should be able to state the physical factors that affect the system, describe how the physical factors affect the system, state the unit of resistivity, calculate the resistance of quantity given a physical factor. So resistance measurement of the material opposition to the flow of current. Copper is a good conductor and has a low resistance. Silicon is a semiconductor, high resistance. Rubber is good insulator and a high resistance. So this is the resistance of the material. One of these shares we have the higher resistance. This is a directly proportional to length. So in this case, because this one, the longer, the more resistance. So the I equal to directly proportional to L. I is a resistance, L is a length. So in this case, R1 by R2 equal to L1 by I2. We have the higher resistance. Then we use smaller cross section area, we get the higher resistance. So resistance is directly proportional to this area. So when the area is higher, resistance will be lower. Area lower, resistance will be higher. So in this case, A equal to pi square by R square. I equal to D by 2, so that A equal to pi D square by 4. So I is a directly proportional to 1 by A or 1 by D square. R1 by A1 equal to R2 by A2. This is already given. The resistance depends on the type of the material. We can call it this property resistance I equal to directly proportional to rho. So here is a material, copper, silver, aluminum, nickel, they are resistivity. So therefore, when you compare the resistance, two resistance, we have to compare the spaces are resistant like this, resistivity. By comparing the resistivity, you can compare the resistance. So R1 with R2 is a rho 1 and rho 2. R1 with R2 is a A2 by A1. So this is for the R1 with R2 is D2 square by T1 square. So R equal to rho A by A. So don't need use substitute. The next one is the temperature, the coefficient of resistance. Not like this session, students should be able to identify the low temperature characteristic for the specified component, describe the resistance affected by the temperature, calculate the resistance component for change in temperature, describe the basic operation of NDC and PDC thermistor. Identify the drawing standard symbol for the specific component. So here is temperature resistance. When the resistance is higher, temperature will also increase. Temperature increase, resistance will be higher. So that will be the higher temperature is higher, resistance will higher is this is a positive temperature coefficient PDC. Now when the temperature is increase, resistance decrease the negative impact. Negative temperature coefficient so NDC. The temperature increase the resistance remains generally constant, zero temperature coefficient. The temperature resistance of coefficient resistance. When the temperature higher, resistance will be higher. So that one will be drawn it. So that will be the temperature of copper. The copper wire is F equal to delta R by delta T. So that this is the R H minus RC minus divided by the TH minus TC. So that will be the resistance. R1 is RA is at 1, RC is at 0, and also the TA is at 20, TC is minus 234. So by this way you can calculate 0.003937. So the copper resistance will be 0.004. So the temperature dependent on the resistor called the thermistor. So this is the PDC and NDC method of thermistor. Then we have to also follow the temperature coefficient. Exercise. Okay, sir. Lesson 8. So we're talking about the linear and non-linear resistor. So we have to revise the resistance and material. Also, you have to revise the temperature coefficient of material. Now, so we continue the linear and non-linear resistor. So at the end of this session, students should be able to describe the difference between linear and non-linear resistor, draw the VI characteristic for the linear and non-linear resistor, use the standard color code to determine the resistance, and describe the resistance of the tolerance and how they are used. Commonly, just select a number resistor for the given application. This identify the VI characteristic of PDI and RDR. So this is type resistor, fit resistor. We will decide this one. When the voltage increase, current increase. So that is a straight line is a linear function, curve will be a non-linear function. Voltage increase, current will increase. So there is a step angle low resistance. Also, this is a steep angle, shallow angle, high resistance, and low resistance. When you draw the high resistance and low resistance in the voltage and the current coordinate, so the shallow angles are this diagram and low resistance is the one. So that we have to specify the resistor by the physical side, power rating. For example, 10 watt nominal value of tolerance, so it is 2.4 kilo plus or minus 10%. So they are common type of the resistor. Carbon, the ray power application, carbon flame, ray power application, metal flame, surface mount, wire mount, valve. So those are kind of this material and their power rating and application. The resistor identification is an IRH. In this case, the first way the brand. And PDB5 is a power rating. 4x7K 4K7 is a nominal value, and also K240 is a construction method. So unfortunately, this is what kind of the color coding of the resistor. So this depending on the resistor, you can have to where the position of the color lie. So you have to utilize the value and you have to multiply with the multiplier. Also, you have to put the tolerance. So that bloom over your garden path violet and grow white. This is the ways resistor will color coding can be no, and by also looking at the display. 4-band resistor color code. First digit is a 2, second digit is 6, double digit indicate the multiplier of 0, number of 0, and final one is a tolerance. 5-ohm resistor, first digit, second digit, third digit, 4 digit, and the tolerance of 1%. So orange, white, brown, and also that will be the 390 ohm plus or minus 10%. So this is the way we get the surface diagram. So this one you have to example. First one is brown, number 1. Second one is red, number 2. Third one is yellow, number 4. And final one is the gold. Goals are 5%. So this is the way that 120,000 ohm. If you count plus or minus 5%, your body will be like this. Here will be the first one is blue, second one gray, 8, third one is silver 0.01, and final one is a gold 5%. So in this case, you receive 68 minus 0.01 is 0.68 ohm, plus or minus 5%. So the plus 5% or minus 5%, then your result will be 0.678 or 0.682. And also the 18 kilo ohms are 1,800 ohm plus or minus 10%. This is for the one is a brown, second one is gray, and this is the first one is a red color indicated by and 10% is silver. So this resistor, so 560 ohm plus or minus 5%, or for the blue or brown and the gold. You have to read there's a gold value in the from the table and you do the exercise. It's 330 kilo ohm. In this case, the first is 3, you have to put the orange, second is 3, orange. That is the 4 digits, so that way you have to put a yellow. And 10% is represented by the silver. So this is the connection type. The resistor color coding. And also you can see that this table, how depend on the position of your color code and also multiplier, and you have to use the tolerance. This is the preferred value. Now is linear voltage dependent resistor, pedestal media. So this can choose a node like this, light dependent resistor. So now this is a practical exercise that you to see the color control code and non-linear resistor. So this table you to read, then will be the value multiplier tolerance of your cable. Now we continue the advanced diploma. So that will be the Bachelor of Applied Engineering, Electrical Electronics, Resources 1.8. On the display, you can see the Electrical Diploma 2022. So Electrical Diploma 2022.
ဒီမှာ professional engineer ဆရာမေးခွန်းကရှိတယ်
electrical diploma ရှိတယ် electrical diploma 2022 you click ရှိပါတယ်
ငါတော့ decline ပုံမှုပြချင်တယ်ဗာမေးခွန်းမှာဖြေတာ
then you see that out option 3 YouTube video or electrical engineering lesson so that E082 lessons are you have to do this as lesson 23 so this is E082 go down and you see the E082 so from the lesson 23 lesson 23 is nuclear physics principle lesson 24 is a nuclear spin nuclear activity and decay lesson 25 is a nuclear model lesson 26 nuclear power generation lesson 27 nuclear fusion so those things you have to view the video after this their notes are here 58 to 86 so you have to click this one 58 to 86 is a video for the go engineering physics so you open this video lesson and see the page of 58 to 86 the page 58 to 86 E082 engineering physics so that today this week lesson is that you have to view the video 23 to 28 Okay, lesson 28, page of 58 to 86. So here is a physics lesson beginning. So those are the beginning of lesson. So you go down up to 58 to 86. Go to 86. So this is 86. So you have to read that lesson 58 to 86. Page of 58 to 86. You have to read through. This is energy. So this is the today. This week you have to read that those are engineering physics. Engineering physics are you read from the lesson 23 to lessons 27, and those are page number here. So this page are 86, 58 to 86. Click this link, you can view the lesson note for the whole video. So you have to view the whole video.